Alright guys, gonna pick up where we left off today, where we left off today, because it's Wednesday night for me, not Thursday morning. So I'm on the PEPA review, number 44, and I've got my curve. It says the average height for females in China is 5 feet 6 and standard deviation is 3. What percent best represents probability one female is between 5 feet and 6 feet? Alright, so average height for females, that'd be my mean, right? That goes in the middle, because that's supposed to be a straight line, not a wiggly line. That'd be 5 feet 6. Sorry, I hit undo and it scrolled. Be 5 feet 6 inches. Yeah. So that's my median. Use the eraser this time, not the undo button. Standard deviation is 3, so 5 feet 6 plus 3 is 5 feet 9. And then 9 plus 3 is 12, and 12 inches is 1 foot, so that's 6 feet. And then minus 3 is 5, 3. Make that a 3 and a 5. And then minus 3 again is 5 feet, and then minus 3 again is 4 feet 9 inches. I need one more than 6, right? So I'm at 6 feet 3 inches. Alright, so 34, 34, 13.5, 2.35. Alright, and I want to know one female between 5 feet and 6 feet. So I want to know between 5 feet right here and 6 feet right here. So I'm looking for that probability, or that percentage. So I am 2 standard deviations away from the mean, and this is a 68, 95, 99.7 rule, so it's 95%. Or you can add up 34 plus 34 plus 13.5 plus 13.5 if you don't believe me. If 370 females are standing around, how many females are between 5 feet and 6 feet? So I'm going to take 370, right? 370, and I'm going to multiply by 95%. 95% is what? It is, 0.95. That gives me 351.5, so I'm going to round up to 352 people. Or 352 Chinese women. Based on this problem. Alright, so looking at 46, average height for males in the United States is 5 feet 10, standard deviation is 2. What percent best represents the probability that any one male is between 5'8" and 6 feet? So I need my curve. I need some percent. Yeah. Middle of my curve, I got 5 feet 10 inches, right? 5, 10. 2 inches makes that 5 feet 12 inches. 12 inches is 1 foot, so that's 6 feet. 6 feet 2, and then 6 feet 4. Going down, I'm at 5 feet 8 inches, 5 feet 6 inches, and 5 feet 4 inches. Alright, so add my percents. 34, 34, 13.5, and 2.35, and then I'm looking for between 6'8" and 6 feet. 5'8" and 6 feet, which is right there what I just erased. Between here and here. That means that's 34 and 34, and 34 plus 34 is 68%. 780 U.S. males are standing around, and I want to know how many of them are between 5'8" and 6 feet. I'm going to multiply that by 68%, and 68% is 0.68 as a decimal. 780 times 0.68 is 530.4. I'm going to round down to 530 U.S. males. Alright. 48 and 49 are just like all these other ones we've done, so you're on your own on those, alright? So let's talk about this new stuff. We didn't really talk about this much in class, so I'm going to talk about it, but don't Anyway. All right, so we're talking about sampling methods and why they're good and why they're not, right? We want to know if butterscotch or tasty treats are more popular at my school. We asked everybody in the senior class, do you like chocolate? You randomly select 100 from all 4 classes. Do you prefer chocolate? You ask 100 volunteers, do you prefer chocolate or butterscotch? You ask the first 100 students listed in the yearbook. You ask the first 10 students that come in the class. You ask every 4th student listed in the yearbook. You list every student in the yearbook and place their name into the hat, draw out 200 names, and ask those students, do you prefer chocolate or butterscotch tasty treats? All right, so going back. We are supposed to determine whether or not the sampling method is valid. Sorry, I'm trying to make my recording screen bigger, and I don't appear to be able to do so. And if not, why not? All right, so we asked all the students in senior class, is that a good approximation of the entire school? No, because we only asked seniors. There are other people at school. Randomly selected 100 students from all 4 classes. Do you prefer chocolate? Tasty? This one's better, right? Better. So, valid. It's a random selection of 100 students. All right, we ask 100 volunteers, do they like chocolate or butterscotch? Volunteers volunteer because you pay them or because they want to do things, and so it's not as valid. So we say no. They volunteered. You ask the first 100 students listed in the yearbook in question. Okay, if I ask the first 100 people listed in the yearbook, I'm going to get what? The A's, the B's, the C's. So no, not a good sample of all students. You ask the first 10 students that come in your class, do you prefer chocolate or butterscotch? Nope. This is called a, it's not. It's a sample. Convenient sample, because it was convenient to you for you to do it. So no, it is a convenience. I'm going to spell that wrong. Oh, maybe I didn't. It's a convenient sample, not valid. All right, we asked every 4 student listed in the yearbook, that one's valid. It's systematic and covers most everybody, right? All right, you list every student in the yearbook, place their names in a hat, and draw out 200 names. Okay, that should not be there because it's, yeah. List every student in the yearbook, place their names in a hat, draw out 200 names, and ask those students, do you like chocolate or butterscotch tasty treats? This is very valid. Covers the entire school population randomly. And so that's what we think. Statistics, when we do statistics, we want who we ask to be a random sample of the population. And that's why the polls you see on TV, on the news, they call people. Well, who answers the phone during the day? People that are retired, people that stay home. But most people who work don't answer those polls because they're at work. Or people who still have a home phone, which, that's becoming less and less and less. That's why we want samples to be random. All right. Jillian wants to know what % of students in her school watch sports on TV. All right, at the next school football game, ask every 3rd student. Nope, not valid. They are already at a sporting event. They probably like sports. So you skewed your data. At the next school assembly, ask every 3rd student who enters whether or not they watch sports on TV. That one's valid. It's systematic. And covers most of the student population. Because you got to assume that some people skip and don't go to the assembly, and you have to assume that some people aren't there because it's an assembly. And not to mention the band and whatever sporting event wouldn't be coming in the main door, right? Because they'd be already on the floor because it's an assembly or whatever going on. I'm assuming it was a pep rally, not an assembly. Sorry. Assumptions. We know what they do. Theo wants to know what percent of students. Theo wants to know what percent of students at his school have a computer. He gets an alphabetized list of the names of all students. Pick every 10th student on the list of survey. That's valid. Valid. Oh, I have caps lock on. Systematic. And covers the whole school. Send an email to every student asking if they have a computer and count the first 50 surveys that get returned. No. If you respond to email, you probably have a computer. Maybe not, but you probably. And so that would be skewed data. Skewed data. All right, so 53, I'm going to let you have that one on your own. 54, we did already. 56, 55. I know we started these. We need to go back over them now. All right, so Noah, you're going to get the rest of the afternoon, the rest of the period to amuse yourself with other things. You got all these characteristics. You can find zeros. That's where it crosses the x-axis. You can find intervals of increase. Where does the graph go up? Highlight it. Remember we did this. There are highlighters on the desk in the back. Intervals of decrease. Use a different color highlighter. I'm showing you the interval of decrease with my cursor at this moment. Or that's one of the intervals of decrease. The other one's over here. Okay. You can find zeros. Intervals increase and decrease. I have faith in you. I expect to see this when I return on Friday. I'm serious, Noah. Serious.